Alright, welcome back. This is the third video on how we can estimate multiple regression analysis using Excel. In the previous two steps, in the previous two videos, we saw how we can get to the coefficients, how we can get to the standard errors, and how we can conduct the t-statistic, the test of hypothesis. In this next video, we will be examining how we can get to the total sum of squares, the residual sum of squares, the estimated sum of squares, but we will also see how we can get to the ANOVA table, the f-statistic, the r-square, and the adjusted r-square. Alright, for our analysis, I have copy-pasted the results of our previous video to this table down here. As you can see, we have the data on columns B through F, and then we also have the y hat we had estimated earlier, the residuals and the residuals squared, and we also have over here the sum of the residuals squared. So we have already estimated the RSS. The next thing that we need to do is we need to get the total sum of squares, which is y minus y hat. So my total sum of squares is going to be equal to, I'm going to open a parenthesis, y minus my average value for the y, and since I want to copy paste this downwards, I'm going to have to lock this cell before I square this value. So I can copy paste this now. These are the elements on my total sum of squares. I can just say that I want to sum all of the above. So my total sum of squares is equal to 704. Now, to estimate my estimated sum of squares, I can go either way. I can simply say that my estimated sum of squares is equal to the total sum of squares minus the residual sum of squares, or I can estimate them via this expression, which means that for each one of the observations I have to estimate y hat, which in the first case was 2.39, minus y bar, which is equal to 9 squared. And once I sum all of the above, I should get exactly the same value as before. So there it is, 366.65. So I'm ready now to construct my ANOVA table. And my ANOVA table I have highlighted over here. My model, my estimated sum of squares are equal to 366. My residual sum of squares are given in column I are equal to 337. And finally my total sum of squares are 704. The degrees of freedom for the total sum of squares are equal to n minus 1, so that is equal to 9 since we had 10 observations. The residual, the degrees of freedom for the residual are n minus k, which means 10 minus 4, which is equal to 6. And finally, the degrees of freedom for the error sum of squares is equal to 3. To get the mean values, I have to simply divide 366 by 3 and 337 by 6, and finally I can get to my f-statistic by saying 122 divided by 56. So my f value is 2.17. Before I conduct the hypothesis, I would like to get the critical value first. And again, we're going to be using both the table as well as Excel. If I use the table, I'm going to have to go to an F table for 0.05 rejection area. And I know that I have 3 degrees of freedom in my numerator and another 6 degrees of freedom in my denominator. So my critical value is 4.757. We can go ahead and write that number down. So the critical value we should get is 4.757. And another way that we can get to this number is by simply asking Excel to estimate it for us. And this is equal to f inv We're going to open parenthesis. We're going to give the level of hypothesis, the alpha level. And then we're going to give the degrees of freedom, which are 6 in the numerator and 3 in the denominator. So my critical value, and I must have done something wrong over here. Yes, I'm sorry. There are 3 in the numerator and 6 in the denominator. I apologize. So there it is, the values are the same. The p-value can be estimated by asking 1 minus f dot dist of my f value. And then I'm going to have to add the degrees of freedom in the numerator, which are 3, and the denominator, which are 6. And I'm simply going to write true for the option of cumulative. And I'm going to get 0.19215. Alright, so let's go ahead and do our hypothesis testing. Let's complete this. So my H null for the f-test is that beta 1 is equal to beta 2 is equal to beta 3, and all together they're equal to 0. And my alternative hypothesis is that at least one coefficient not equal to 0. I can draw an F distribution over here. We know that the F distribution is skewed. So my rejection region is going to be to the right. So this is my H1 region and this is my H null region. My H1 region is a total of 0.05, and my H null is 0.95. We have already found our critical value to be 4.76, and we have also estimated that my F for the specific regression is 2.17. So my F falls in the H null region, which means that I cannot reject the hypothesis that all of the coefficients are equal to 0. And as you remember, the data that we have used is simply random data that I have created for the purposes of this example. Alright, so in this case the model is not significant, but for the purpose of the analysis we will continue with estimating the R-square, the adjusted R-square. One more way with which we could have gotten the f-statistic, and I'm going to get back to this once we estimate the R-square. Now the R-square is simply the estimated sum of squares divided by the total sum of squares. So it's 366 divided by 704. So my R-square is 0.52. Since we have multiple regression analysis, I will interpret only the adjusted R-square. So we'll need to estimate that. And this is equal to 1 minus. I have on the numerator n minus 1, 9. On the denominator I have 10 minus 4, 6. And I'm going to need to multiply that with 1 minus my R, my simple R square. So this is 28. In other words, the model we have specified explains 28% of the variability in the dependent variable. Finally, if I could have gotten to the f-statistic by using my R square value. So my f-statistic would have been, let me take this a little bit further down. My f-statistic would have been equal to my R square, 0.52 divided by k minus 1, in other words divided by 3. Those are my numerator degrees of freedom. And again, this has to be divided by 1 minus R square divided by my denominator degrees of freedom, which is 10 minus 4 or 6. And once I press enter, I should get to the exact same value as I did before, 2.17. There it is. So we have completed this exercise. We have estimated the coefficients in the first video. We estimated the standard errors and conducted the hypothesis testing for each one of the coefficients. And then in this third part, we finally got the ANOVA table, the R-square, and the f-statistic. What remains in this exercise is for us to replicate those results with Stata and SPSS, which we will do in the next couple of videos. What you have available for your own exercise is you're going to have this file available to you on my website that you can download. I will post my website again at the end of this video. You have two sheets down here. On the sheet that says solved, you have the solution to this exercise, which you can get back to in case you get stuck. And then you will have the sheet that says work on, which will be empty. It will not have the solution, so you guys can work on this exercise. You can try to get the coefficients, the standard errors, the t-statistics, the ANOVA table, R-square, and F value. You can get them on your own. And that's it for this video. Thank you very much.